Good morning. Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
So, how is everything?
Good morning, sir.
Very good morning.
Very
Yes,
good,
sir.
sir.
Everything nice.
Everything nice, fantastic. And yesterday we were in that mood of celebrating our 73rd. Which day?
Republic Day.
Republic Day.
Republic Day.
Also, sir, Independence Day,
Republic
sir.
TV, Republic TV.
Independence Day.
Okay. Now, do you find any page shared there on your screen?
Yes, sir.
So
Yes,
we
sir.
started for that method of section for solving trusses. For several cases, method of section is rather very efficient. Suppose if this truss is too long, suppose a bridge truss, and somewhere at the middle you need to find out to value of the member force for a particular member very far from this conventional approach of taking up a joint near that structure, support, etc. So for such cases, now there may be of different situations. Now, first difference is for method of joints, you can solve only for two unknowns because it is a concurrent coplanar force system. But for method of section, you can solve for three members also, where this is the case of coplanar but non-concurrent force system. The first step, conventionally, what you do, find out the reactions at the supports. Then we go for these members where you have been asked to find out the force, determine the force in members CD and DF. So you have to select a section which should pass through CD and DF. If more number of members you need to find out, and if that section, plain section, will not give you the members included or being cut by that particular section, so naturally you need to take up another section, but that is different part. First thing, we need to consider one section and find the equilibrium or consider the equilibrium of any of the sides, either left with respect to the section or on the right. So this is the case. We consider this section which cutting this member CD and this member DF, which are required to find out their member forces. Now we consider the right hand side for equilibrium. So the forces in the members are shown in this way, assuming tensile as usual, like that method of joints. Give the names, either 1, 2, 3 might be given for these members, or these names also you can use. This is for member CD, this is for member DF, and this is for member AC. Normally we prefer to write the first letter first.
Sir, one doubt is there. Sir,
Just soon.
Okay.
Sunte ja. So these three names, whatever way you prefer, you put them. Then consider the equations of equilibrium. Equations of equilibrium, there is your liberty. How to frame those equations of equilibrium? It may be conventionally sigma fx0, sigma fy0, and sigma m0 about a particular selected moment center of your convenience. Or you can select three separate distinct moment centers where these three locations are not collinear. Next thing, if we consider this SAC and SDF, both of them are horizontal, and only one unknown force remaining there, SCD, which is vertical. So directly from sigma Fy is equal to 0, you can find out the value of CD. So RJ positive -12 minus SCD. So SCD will be RJ -12 RJ is most likely it is 15. We calculated. So 15 minus 24, that is -9. So this will be under the member force of -9 kilonewton, that is opposite to the direction whatever we have assumed. So it will be compressive with magnitude 9 kilonewton. Next thing, sigma MC is equal to 0. It gives that facility that in that equation of moment equilibrium, the forces CD and AC are automatically eliminated. So only this unknown force remains there, SDF. SDF multiplied by this distance, that is clockwise negative moment according to we have decided anti-clockwise positive moment. Otherwise you can select clockwise positive, whatever you feel convenient for you, that you can do. So SDF multiplied by this distance CD clockwise, then 12 kN multiplied by this 2.4 meter clockwise, 12 multiplied by 4.8 clockwise, and RJ multiplied by 7.2 anti-clockwise, and you solve it, get the value for the DF. For AC, you have not been asked to find out, but if you need to find it out, you can use sigma fx0. For x direction, 12, 12 RJ and SCD do not have any contribution. Only thing minus SDF minus SAC. So SAC will be equal to minus SDF, and you very easily can determine it. Now you tell me, somebody was having some doubt. Okay.
Yes, sir. Sir, while cutting the plane, sir, which part we'll consider and which part we'll neglect, sir? That was the doubt. After cutting it, which part will...
After cutting, it is according to your experience. So whatever you get from your experience, it is like that. If we consider the right hand portion, how many forces are there? 1, 2, 3 given forces, and in the moment equilibrium equation, 1, 2, 3 forces you need to consider. But if we consider the left hand side, suppose in some letter diagram, yes, it is there. So there only one force RB is there already calculated. So sigma Fy0 will directly give you SCD having only one force RB. So SCD plus RB is equal to 0. So SCD is equal to minus RB. Most likely it is 9 kilonewton. So it is 9 kilonewton compressive. The same result. Whether you consider the right hand portion or the left hand portion with respect to this section, that will come from your experience, which helps you to minimize your calculation effort, your drawing effort, your possibility of making any mistake or error. All such kind, it should come from your practice. There is no such hard and fast rule. So if I consider the left hand side, so only one force is required to be considered there. Now, if we consider this point as moment center, sigma MC is equal to 0, how many forces are there? Only one force RB multiplied by 2.4 clockwise, and this SDF, which force you need to determine, SDF multiplied by this distance, most likely it is 1.2 or something like that, 1.8 or something like that. So in that equation, there is no 12 kilonewton contribution coming from them. So it is helpful for us. That equation will not be long or longer compared to this situation. Okay, so it is up to you. Now, for this given problem, the reaction, consider the section right hand side or left hand side. We approach in that way and we find it. You will find the same result. Okay, but direction of SCD here is upward and direction of SCD here is downward. Nothing to worry about that. We are considering two different portions for equilibrium, but nature of that member force is same. That is tensile. For this tensile, it is acting away from this member or along the member, away from the joint, and for this case, along the member but acting away from the joint. Okay. Now, if we are asked to find out forces in the member FG and FH, here also the same thing. You can find out the reaction. You can consider the portion on the left with respect to this section or portion on the right with respect to this section. But how many forces are here on the right? One given, another reaction. On the left hand side also, one given force, other is the reaction. Only thing, their distances will be different when you consider the moment equilibrium equation with respect to some suitable distinct location whose distance or geometrical information is supplied there. Okay, so in this case, nothing to worry about that. Now, if we consider the right hand side, how we eliminate the not required member forces for determination of a particular member. Suppose we want to find out the force in the member FH. So for FH, G will be the suitable location to consider it as moment center. So sigma mg is equal to 0 will give you SFH multiplied by this distance 1.8, that is clockwise, and Rj multiplied by 2.4, that is anti-clockwise, and selection of this point G as moment center will directly eliminate the contribution of 12 kilonewton and contribution of SFG. Okay, so one equation with one unknown, solve it, SFH. For this one, for this inclined member, we use, pardon?
Sorry,
Hello?
sorry.
I don't understand what you are talking about. Anyway, might be some household noises. Okay, if we go for this member FG inclined, what about other members? 12 kilonewton vertical, RJ vertical, FH horizontal. Now, if we want to eliminate this horizontal and this horizontal forces, naturally we need to consider sigma Fy is equal to 0. In that sigma Fy 0, Rj minus 12 minus this force SFG multiplied by sine of that angle made with the horizontal. So you are eliminating the contribution of this force and this unknown force. So one equation, only one unknown. Okay, so and from left hand side also you can approach and do it in that way. So this one sigma Fy0 will directly give you this value. Only thing, this angle is to be determined. What about this angle? This is tan inverse 1.8 divided by 2.4. So that is in the ratio of 3:4. 0.6 multiplied by 3, 0.6 multiplied by 4. So for 3:4, what about this hypotenuse?
5, sir.
5. So sine theta is 3 divided by 5 and cosine theta is 4 divided by 5. So you don't need to bother your calculator to get that inverse of 10. Okay, so only by observation you can find. But if you don't want to bother your brain for such storming, you can use your calculator. But these things are very helpful if by observation you find that your examiner or paper setter has set such values which are numerically very rather convenient for you. Okay, so anyway, that's up to you. But as an old and senior citizen, I normally prefer my old student life. When I started my graduation during my BTech, in my first year, there was no calculator in the market. In second year, we got calculator, but that too, as I live in West Bengal, so in West Bengal, there was only 2 locations where the pirated Japanese calculators were used to come. Most likely it was FX21 or something like that. So one place is there, Bagri Market. If there is any West Bengal people, you can understand. And another is some Khidirpur, some dock is there. The name is Fancy Market or something like that. So those pirated, anyway, officially I should not disclose these things. And there.
Sir, you have done your BTech from NIT Durgapur?
No, from then BE College, Bengal Engineering College. क्यों बेटा इतने पर्सनल सवाल क्यों पूछ रहे हो? अभी मैं टीचिंग प्रोफेशन में हूँ. Of course, it should not be called as a profession. It's a rather we are working as service provider to you people. Of course, not NGO. It is GO. So, corresponding to all these requirement, you have to select the cutting plane, etc. And from directly from sigma Fy0, you get this one. From sigma mg is equal to 0, you are eliminating this horizontal and this inclined, so you are getting this force. And similarly, about this point, sigma mf is equal to 0, will eliminate these two forces. Only this thing is left there. So please do some practice. I hope you will build up confidence. Now, did I discuss about this problem?
No, sir.
No, sir.
Now, here is this vertical structural framework, a plane truss. Forces are applied horizontally. Suppose this is representing a person who is standing vertically and your foot is attached to the ground so that you cannot move. But from your backside, at your neck, at your waist, at your knee, suppose some wind thrust is coming, or some of your bad friends, they are trying you to push you in that way, but you cannot move, you cannot walk because your toe is attached with the ground. Now what will happen to your this body? अरे बेटा simply you झुक जाओगे इस तरफ, you try to lean forward.
Shear
Okay.
stress होता है book में.
और बेटा shear stress बात कर बेटा, अभी नहीं है? और फर्स्ट सेमेस्टर में तो है ही नहीं, मैं कुछ भी नहीं बताऊंगा about shear stress. This is perfectly rigid members, and if you are subject to those forces from your back, naturally there is a tendency of you to lean forward, or there will be tendency of tilting. So if you consider this structure, so that tendency of getting that clockwise rotation about this point to be supported by the reaction here at K. So moment developed due to this 5 kilonewton, 5 kilonewton, 5 kilonewton at distances 3 meter, 6 meter, 9 meter heights. So this summation of clockwise movement will be balanced by this reaction force at roller at K, which will provide that anticlockwise moment. That moment equilibrium equation about J will give you the value of reaction at K. That is the first step. Now, what about the reaction at J? It is a hinge support. So there is a possibility.
Two reactions.
Huh?
Sir, at hinge support 2 reactions each, and in roller support 1 reaction.
At a hinge support, if we consider the special situation that sigma fx is equal to 0 for this case, for this special situation. Now in that sigma fx 0, there is one, as we consider, one horizontal component of reaction, suppose rjx, there is the force. What about the other reaction? Here is only vertical reaction, it is a roller support beta, you must remember. Now how many such horizontal forces are there? There is no contribution from this. So only one horizontal reaction is developed here, and that too minus rjx. That is one thing. Others are 5 kilonewton positive, 5 positive, 5 positive. So directly from observation you can find this value is minus 15 kilonewton negative towards left. And what about this value? Conventionally we find that rjy, the vertical component, from sigma mk is equal to 0. So 5 multiplied by 3 clockwise, 5 multiplied by 6 clockwise, 5 multiplied by 9 clockwise, plus rjy multiplied by 4 clockwise. So find out that thing. Otherwise, as these applied forces are not vertical, so in vertical direction, how many forces are there? No applied force, only two reactions at K. Rk is vertical only, vertical upward. So here it will be vertical downward. Okay. So by observation, you can say this value will be downward, as if it is pulling towards the ground, the backside of your toe, so that you are not allowed to lean forward. Okay. And to prevent that forward leaning or tilting forward, here is that your fingers are offered this offered by the ground this reaction Rk. So one situation DG and F, just hold a minute. So when we have that special type of situation, by observation, using our common sense, we can find so many things. It is very helpful. But you need to be very intelligent, clever, smart, and opportunist. Anyway, opportunist word is quite big meaning. And some meaning are also not great. So anyway, please don't mind. So first case, you find the forces for DG and FI. Now, according to our previous knowledge, what we are used to do, that DG and FI should be intersected by a plane. We have to select the plane in such way and consider the equilibrium of any portion. Now, this is our, this is the calculation of reaction. From sigma j, we get the value of Rk. From sigma Fy0, we get the value of Rjy component, and here Rjx component from sigma Fx0. One more second. So by our previous knowledge, if we consider a straight horizontal section, how many members being intersected by that plane? It is two vertical members DG and FI, then two inclined members EG and EI. But physically these points D, E and F, these are not present there, but to show those presence of those joints in the original structure, we are showing this thing. But we have cut this by this imaginary plane. Okay. Now next thing, for this equilibrium, how many unknown forces are there?
Sir, 4.
4. Now these four unknown forces, can you solve from this non-concurrent coplanar force system?
No, sir, because 3 can
No,
be
sir.
solved.
Normally
Only
not
3 can be
possible,
solved.
because if we consider this point G, I'll just so if we consider this point G as moment center, so how many forces are eliminated for the members DG and EG? But two are remaining unknown. This one and this one. Similarly, if we go for this moment center, I, this is eliminated, but these two are remaining as unknown. You cannot solve it directly from that equation. And if we consider sigma ME is equal to 0, it eliminates this one and this one, but these two remaining unknown. So you cannot get such three independent homogeneous equation which can help you to solve this one. So to avoid such situation, we need to utilize some special type of section. Here is the clue. You don't need to select one flat cutting plane. It may be curved one in that way. So when you use this cutting plane, what you are getting? This plane passes through this vertical member DG, vertical member EI, and these two horizontal members DE and EF. And for this particular situation, if we consider this point D as moment center, then this force, this force, this force, and this force, these are the four forces to determine, but this one, and this one are directly eliminated because this point D is that point through which these three lines of actions are passing. So only this thing remains, and we can solve it very easily from that single equation, a single unknown, solve it directly from that equation. But situation may not be like that always. So for those situations, you have to utilize your experience and common sense. Okay. Now, it is not mandatory to consider always the supports included there. So with reference to this section, either you consider the lower part for equilibrium, overall equilibrium, or the upper part compared to this section, which is not a single flat cutting plane, it is a curved one. Now for the members DG and FI, if we consider the lower part, so these are the four member forces for those members which are being intersected by this cutting plane, and we need to find out. So the section name is AA, small a. Then naturally you can find out very simply these things. But one thing is there. From this point D, if this point D is considered as moment center, then this is eliminated, this is eliminated, this is also eliminated. So you find this one. Now once you find this force, then what remains? Other three forces, that is this one, this one, and this one. Now any special idea you can utilize now?
Moment about
Now is there any contribution from these two horizontal forces?
No, sir.
So only this sigma Fi plus sigma dg, that is equal to 0. So sorry, well, not sigma Fi, this is Sfi plus Sdg, that is equal to 0. So Sdg is equal to minus Sfi. Now if you determined this Sfi as compressive, then now Sdg will come as tensile and vice versa. So this simple idea you can utilize very efficiently, but for that you need really good practice, and a single 45 minutes class, lots of discussion by your service provider really will not help you until unless you augment, supplement, or complement all this discussion with your own contribution. Now that is for DG and FI. If we consider another section BB, and it is not like a single straight line like thing here, and even if we consider the lower part including that supports, so this is the thing. So sigma mg is equal to 0 will eliminate directly force in the member gj, gh, and hi. So this is known now, calculated for the member ik, and sigma fy is equal to 0. You can get this value. But one thing, you did not made any protest for that mistake what I made. When we consider sigma Fy is equal to 0, these two, this is known, this is unknown. But what about these two?
Is also yes, sir.
So you need to include that. So sigma Fy0 will give you S Fi plus S dg plus
Sir, they're equally and opposite in directions, so it will get
Yes,
cancelled.
sir. They will cancel each other.
Which one?
So RK and RJY.
Exactly. Rk and Ry, they will cancel each other for this special situation. But if by any chance here is a force which is not horizontal, it is inclined. So for this particular this thing, they will not be equal. So you need to consider all such aspects which give some special help for you. Otherwise, you have to approach generally if the special situation is not given like this inclined force is there. So nice thing that you give me that good suggestion, because Rx and Rjy are of same magnitude and opposite direction. Okay. Now, according to our convenience, we let me erase this extra information which is making the diagram clumsy. The next thing, the upper part. Here, there is no such Rjy and Rk. So now it is okay. Sigma Fy will give you directly the value of dg or Fi if one is known already by method of by that sigma m is equal to 0. Okay, so this is the upper part equilibrium. Here this is also that upper part equilibrium, and we can solve this by suitable selection of moment center, etc. But that moment center to be selected in such a way which can eliminate the maximum number of unknowns. Okay, and for that this joint G is suitable one to find out this Ij, rather Ik, I think, and here it is J. So member Gj and Ik that you can find more comfortably if we consider the portion above this cutting plane. Okay. Now, is there any question about this discussion on method of section? Okay, you think for.
I guess the
Ij?
sir, do we need to find moment to find the value of the force members?
Now, thing is that when we go for suppose what about the name S Gj and S Ik, and this is S. What about the name of the joint? H, I think. S H I, and this is S G H. Okay. Let me see it first. Yeah, it was at H. So these two member forces you need to eliminate, and normally we do it by method of by moment equilibrium equation. Now these two forces are horizontal So if we consider sigma Fy0, these two are automatically eliminated. These are also eliminated from that equation. But this equation gives minus Sgj minus Sik, that is equal to 0. But from this one equation are two unknowns. Is it possible for you to find the value of these two members Sgj and Sik? Only thing you can get a relation that these two are of same value, opposite magnitude, same magnitude, opposite direction, opposite nature. But that's all, nothing more than that. So sigma Fy is equal to 0. You cannot get the exact value of these two members. Sigma Fx0 will not include this. Okay, so sigma Fx0 will not help you to find out Sgj and Sik. So that's why you need to consider that sigma M0 about some suitable location where out of 4 unknown forces, 3 are eliminated automatically. And for that, the suitable location is either the joint G
Or I.
or I. Okay, now either of these will give you one solution. For G will get this, for I will get this one. Now once any of them are solved, then sigma Fy is equal to 0 will give you very simply the other force. Okay, now before going to any further discussion, I will finish that important job, that is attendance.
Hello, sir.
हाँ बोलो.
Sir, I require attendance for verification of UP scholarship form. So what I should do?
You discuss with your Dean Academic, Professor Nirmal Boron Hui of Department of Mechanical Engineering Department. In your website,
Yes,
you get every detail, mail ID, phone numbers, etc.
Sir, I had mailed to HOD of mechanical engineering, so he said that contact to your teachers and they will give you individual and compile it.
Individual teacher will give you some individual to whom it may concern like thing. But the scholarship you are applying for, do you have any specific format where you need to get endorsed by your class teachers? So first you inquire that.
Sir, they have only asked for percentage of attendance.
तो फॉर्म में कहाँ लिखा है? जहाँ लिखा है उस जगह
ऐसा
पर
कोई
देखो.
फॉर्मेट तो
और
नहीं दिया है.
कुछ फॉर्मेट नहीं दिया है तो यू आर राइटिंग ऑन प्लेन पेपर. बेटा ऐसा
Yes, sir.
ना, ऐसा होता नहीं. व्हेन यू आर आस्किंग, एक पंचायत में अप्लाई कर रहे हो क्या? विलेज
No,
पंचायत
sir.
में नहीं ना. ये तो कोई
No,
ऑफिस,
sir.
कोई ऑफिस है, गवर्नमेंट डिपार्टमेंट है, कोई स्टेट
सर
स्कॉलरशिप
दुर्गापुर में
है,
भेजे
एससी
तो उन लोग
स्कॉलरशिप,
को
एसटी
वेरिफिकेशन
स्कॉलरशिप,
के लिए
ओबीसी
चाहिए.
स्कॉलरशिप, कुछ तो है ना बेटा. और डिटेल भेज मुझे, कहाँ से मिला तुझे स्कॉलरशिप पे इंफॉर्मेशन, फिर मैं बताता हूँ. ओके
ओके सर, मेल करते हैं सर.
Hello, sir.
Hi beta. Let me check once whether that attendance is downloaded or not, because sometimes I get some problem. It shows that no, it has not been downloaded. So okay, on today's date it is showing that meeting attendance list. Anyway, we were talking about here. So any moment center will give you that value of the required member force, and sigma Fy is equal to 0 will give you the other one. Okay, now please go through book, any book. I do not have any reservation, but you have to do it. Now I will ask you, to think about this. Here is a truss. Two supports are there connecting this horizontal member AB. Hinge support at A, roller support at B. Now this triangle ABC is one equilateral triangle. Length of each side is A, small a. Now another equilateral triangle DF is there, and these are connected by these members AD, BF and CE, and geometry is very simple. From this 60-degree sides, 15-degree deviation, 15-degree deviation, 15-degree deviation, these three lines are drawn, and along this vertical line of symmetry passing through this point C, on this line of symmetry, here is one end F, and then we identify the 60-degree lines and get the locations DE. How to draw it geometrically? It needs little other investment. Your way of thinking, implementing with the drawing instruments, pen, pencil, eraser, etc. Just think about how to do it. Now, only one force P is there applied vertically downward at the joint F. And you have been asked to find out the force in the member AB. Now, conventionally, what we start with, that is determine the reactions at A and B. This is a simple situation. Geometrically, it is symmetric. Loading wise also it is symmetric. So what about the reaction at A and B?
Sir, P by 2 upward.
P by 2,
P by 2 upward. Fantastic. Now, for this joint A or this joint B, to start with, what will be the free body diagram? The free body diagram of joint A will be, just hold a minute. Free body diagram of joint A will give you three members, one member along AB, other force along the member AC, another along the member AD. Give these three names, and there will be one reaction RA that is equal to half P. This force is SAB, this is SAD, and this is SAC. Angles are known. This is 15 degree, this is 60 degree. Now can you solve this joint by method of joints?
No, sir.
It is
No,
not
sir.
possible. At A, it is not possible. At B also, here are three forces not possible. At C, it is not possible. D or E, F, all are C-member joints. So, method of joints is not at all possible for this situation. In some previous class, I told you that we can solve by method of joints or by method of section or by mixture. But if the situation comes like this, even if it is not mentioned in your question that solve it by method of joints, you are compelled to solve it by method of section only. If it is not, you are not asked to solve it by method of section, then you can try with method of joints, but you will not be able to solve it by method of joints. Method of section is the only possibility that you can solve it. So let me move back to the original diagram. Now, can anybody suggest about the section to cut this structure?
Sir, parallel to BC, cutting AC and AD and AB.
Cutting AC, AD and
AB.
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 EB, EB तो कोई मेंबर नहीं है बेटा.
AB sir.
AB,
AB, अगर AB हुआ तो वो तो यही हुआ ना. मेथड
sir.
ऑफ जॉइंट्स, वो तो
Parallel
मेथड
to
ऑफ जॉइंट्स हो गया. वही हुआ ना.
we can write moment equation no, sir.
Moment equation, fantastic. Now moment equation about point A will give you all these three forces eliminated. Only RA is there. So RA multiplied by 0, SAB multiplied by 0, SAD multiplied by 0, SAC multiplied by 0. So 0 plus 0 plus 0 plus 0 is equal to 0. Very good equation to give you that help. नहीं होगा, नहीं चलेगा. Any more good suggestion?
Sir, about point B.
About point D?
B.
This one. About point D, there will be two unknown. This is eliminated. About point B, unknown, unknown. One equation, two unknowns. Can you solve better? Not possible. And you can try other options also. But primarily you must understand concurrent coplanar force system will not give you solution more than two unknowns.
Sir, can you repeat again, sir?
Repeat which one?
The last one, what you told.
From your friend's suggestion that if we consider this joint and consider this point B as moment center, then this force is passing through this joint B. So in that moment, sigma MB is equal to 0. In that equation, there will be no contribution from AB, but there will be contribution from these two member forces, SAC and SAD. This is known, but that equation sigma MB is equal to 0 will contribute, rather will get contribution from these two unknown. So one equation and two unknowns. You cannot solve it. Suppose
Sir, we can write equilibrium equation no, sir.
Sir, we can solve it by taking moment
Fx
equation
equal
at
to
point
0 and
C,
Fy
sir.
equal
Sir,
to
at
0.
point C, moment equation at point C.
Moment equation at point C.
Yes,
Okay.
sir. We can get the value of AB.
At C, then
Yes, sir.
it is eliminating this one. Eliminating this one, but not simultaneously two forces. This is AD is remaining. AB is remaining. So one equation, two unknowns.
Sir,
Again.
we have another class, sir. It's 11 already.
Okay. So please don't ask any more question. Let me give you a good hints about this problem, and you try.
Sir, leave it today, sir. Hint. Leave today hint, sir.
Just 1 second, I will
Tomorrow.
because it is 10:57. 3 more minutes are there. You can move there. Only
Sir,
thing
in next class, sir. In next class, you should give, sir. Sir, in next class, you should give hint, sir. Leave
just
it
1
today.
second. जितना बकवास कर रहे हो 1 मिनट चुप हो जाए बेटा. Just consider this cutting plane, and there these three are the unknown member forces where you can get intersection of any two unknown forces. That's all. That is my hints. अभी next class में join कर.
Sir, I am saying that, sir, leave it on us. We should think for one day, and after that, next class, you should take hint. That's what
No.
I am saying.
I cannot wait for your 1 day wastage. This will not be 1 day wastage. It will be 1 week wastage because on Monday we are getting our next class. Now with these hints, you do that practice.
Okay, sir.
Okay.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. बोलना बंद कर, next class join कर.